All right, I think we're on. I just wanted to give it a second to make sure the stream was up. Um, yeah, probably we'll do the usual where I'll wait until, 5 after the hour to kind of start diving in. But today we're going to cover Lab 3, which was due 3 minutes ago, technically. But you can always submit it later, use a flex day or whatever. But we will be going over the four, I believe, functions found there. And I don't think it'll take the full time. So we'll definitely have time for questions, but again, you can ask questions throughout. And if we do have extra time, which I believe we will, then I will probably start going over word match, or at least some hints to go over word match, which is a function for homework 3, which I think is probably the most challenging of it. So, I'll go over some like kind of things you can use to help solve it, but obviously I will not solve it yet. And I won't be probably going over all the kind of homework items um, because the last office hour video I did Tuesday, I kind of gave hints for the lab and the homework functions. But I did touch on word match, but again, I'd like to go over some kind of like string manipulation things you could do just in case. And then hopefully, as we go over the lab today, if you did have any kind of problems with it, that they'll be clarified when we do go over it, and that you could potentially use some of these, like tips and tricks and programming stuff to help you with the third homework. All right, so I'm gonna go ahead and start. It's like 4 minutes into the stream. It is like 5 after now, so I'll just go ahead and start. Which I will begin by opening up the lab instructions, and I already kind of have this blank Python file. So we'll start with the first one. I don't, yeah, I think it's fine if we use this, right? I don't think I had any like hard-coded stuff in here. Like I know the pizza topping one from the homework has the list of toppings, but we should be fine to just do it like this. Cannot spell. So complete the function vowel counter. It takes in a word, it takes in a single string, and returns the number of vowels present in the input string word. So I read that, and I'm going to know, all right, so word's going to be, a string. Maybe we'll do test. And it says it's going to return a vowel, or return the number of vowels present, right? So to return, and I'm going to go ahead and put 1 because I think like all words have to have like at least a vowel. I'm sure there's some exceptions, right? But like most words have a vowel. So I'll just go ahead and put my default value to 1, but I know I'll want to change that. The input word might have varying cases, such as apple and apple. So one has a capital A, one has a lowercase a, both of which have an A and an E as the vowels. Okay, so in that case, we would return 2. So, maybe I would want to write down something like that. a little test case thing there. And it might make your code a bit cleaner if you used a particular string method to reduce how many checks you'll need to do. Like, okay, click this. Oh, it's the W3 school thing he always links to. That is correct. So, maybe I'll look for something in here, but we'll see if I need that now. Maybe I won't need it. The vowels to check for are A, E, I, O, and U, so we're leaving off that sometimes Y thing. And thus the call of a vowel counter testing would return 2 since there's one E and one I. Okay, so maybe I'd want to actually just go up here, and that would return 2. So I know I need to check for vowels, so maybe I want to store them in something that we recently learned about. A, E, I, O, and U. Whoop, there we go. So maybe I want to iterate through this list, or basically use this list, right, to check for the vowels, because these are the vowels. But then I'm like, oh, so maybe that's what you're getting at with the whole Apple lowercase and uppercase thing, because the string like this would return false, right? Because it's a little bit different casing, but like this would return true. So it's like, okay, well, how would I handle then if they put in, yeah, I can check for Apple, right? So maybe I'll just go ahead and do that case where I check for Apple. So let's check for Apple. Okay, so I have my list of vowels, and then I'm gonna need to count the vowels. So maybe I'll put a counter here, and then I can be like, all right, well, I won't return 1, I'll return whatever this vowel count is. Because that's ultimately what we return, right? So it's kind of telling me, hey, if you need to check for these vowels, you need something to keep track of how many vowels you found. So it kind of lends itself to like a variable representing an integer, which is the count. So I'll go ahead and just initialize that to 0. And now I'll want to go through the word, but I want to go through it like letter at a time, right? Because I want to count each vowel. So I'm like, all right, how would I kind of get the different letters of a vowel or different letters of a word? So I know I can do things like that, right? Because you can kind of treat the same with like a list, right? So you can like index into a string and get the character at the individual index. So I'm like, all right, maybe I could do that. And we did learn about like loops last week, right? So maybe I would want to kind of iterate over the different letters in the list somehow. So like, what if I did 4x in word? So, maybe at this point, right, I do for loop and I'm like, okay, what's this gonna return for me? Right? Because I may be unsure. So I did a for loop. I have my, for x, for I, for whatever. And sometimes you could do, so I could do, right? Oop, probably need the range on here. So I could do something like that. And, we've done loops with range before, so I know this is gonna, right, return like a number. So it's okay. And, the 0 is for count, so not to be confused. All right, so that's cool. And then I can kind of index into the word that way to kind of get my letter, right? So then I can do like word X. Probably copy this. And it's like, oh, okay, well, that gives me the letters. It's kind of nice. Another way you could also do it, which is like maybe not the most apparent one since we've been used to doing it more of the range way. But if you do something like this, right, just like 4x in Word, there we go. You'll notice it also gives you the same thing. So if you just like have in and then the thing you're doing it on, the iteration on, is a string, it'll actually give you the characters for it, which maybe you knew or maybe you didn't, uh, but you can always experiment with it. But like, otherwise you could just do the whole range way, which I think might be maybe like more familiar because maybe more familiar because we kind of worked on that for the past homeworks. Give me 1 second. Yeah, so we can do it, either way, but we get the characters and the letter. Um, okay, so now so I know X is now this letter. So, maybe I could name it letter, but we'll just keep it X. So I want to see if the letter I have is a vowel. So, and then if it is, I'm going to want to increment it. So even just like talking about it, I can say like if the vowel or if my letter is in this vowels list, then do something. So also we're on conditional week, right? So maybe I will want to do it in if. So if my letter, and then I want to like know if my letter is somewhere in here. So, maybe I would want to do another for, which is sometimes common. So if I wanted to do like this and vowels, and then do a little comparison here. So it's like my letter A, if it's equal to the current vowel we're in, do stuff. But also with lists, you could do, oh, we already have there. So if X, so if the letter, and then you can just use the in keyword is in vowels. So this is basically saying, so if you just like this syntax here, X and vowels, which will return like true or false, it basically looks at what this is, which is a string which represents a single letter, and checks each element of this kind of list, vowels, and sees if it's in there. So it's kind of doing that for me, but it's also returning true or false. So it's lends itself to be used for a conditional. So once we have that, then if X is in vowels, so if X is a vowel, we will want to increment count. And so remember, this is the same as doing count plus one. And that's kind of it, right? Because we just wanted to count the vowels. So if it is, add to this count. Oops, that's the one. Then return the count. So, if the if doesn't get hit because the letter is not a vowel, then it'll just ignore that. So we don't really need an else. So let's see if that'll work. Okay, so it does give me two, right? So it gets the A and the E because those are in the vowel list. But how about this? Okay. So it doesn't find the capital one. So one way to do it is I could just take my list, right? And I could do the capital versions of each letter, which is fine. If you did it that way, that's totally fine. But maybe if you like don't kind of want to add these 5 letters, you could do, which is what this kind of string thing was getting at, right? A bit cleaner if you use the string method. So I'm like, okay, I'm looking for something that deals with the casing of letter. So like, maybe I want to look for case. I don't think capital will work, but like lower and uppercase. So you could also search for upper, or you could just kind of scan these each quick. I mean, I don't know. There's probably like what 15 on here. Um, but this one, the lower method returns the string in lowercase. So, I look at this, I'm like, okay, hello world. They print it out with lower. And if you click the run example, you can see, oh, it makes the H and the W go to lowercase. So then maybe I could just use that on my input word, and then the capital A apple will become lowercase, right? And so let's try that. And indeed it does. So now you and I could pass in like everything all caps, and then we'll just show you here. Right, makes everything lowercase. Hold on, let me. Yeah, so that kind of covers, right, vowel counter. And again, if you have any questions on that, or if we're working on the other functions and a question comes up, definitely feel free to kind of chime in. And so we'll move on to this next one, which is completely odd. I feel like I can never spell the word completely right. Okay, so write the function completely odd that takes in an integer num. Okay, so maybe we'll say, let's say num is 5. This function should return true if all digits in the number are odd and return false if otherwise. So, maybe I'm a little confused when I still read that. For instance, 93751 would return true, but completely odd 9329 would return false since 2 is an even. Okay, so it goes like digit by digit and tries to see if it's an odd, if everything's odd or if everything's even. So I said, we'll return a Boolean, true or false. So I'll go ahead and say return true right here. And now I need to check for even or odd, and I'll need to go through like a number, like a digit by digit kind of thing. I guess technically we would do that first, and then check for even or odd, and true if they're all odd, false if even. Okay, so immediately when I see check for even or odd, I might remember kind of the modulo function that we did. So, like 10 modulo 2 is going to be equal to 0. What's like a better case, actually? So 10 modulo 7, right? It's like 7 can go into 10 once with 3 left over. So you can think of modulo as kind of giving you like the remainder. And so by that, and if you're also, I forgot which section it is, and I believe it's Introduction to Programming with Python. There's some talk on the modulo. And we used it in the past homeworks as well. But conveniently, kind of modulo 2 on an even number is always going to equal 0, right? Because by the nature of an even number, it's like always divisible by 2. And then 0 kind of has an odd case where 0 modulo 2 is also 0. And that kind of gets into number theory on like, is 0 even or odd? Which is why kind of, did I include this? Yeah, the 0 is an even number. But, so it's like 6, which is an even number, modulo 2 should equal 0. 84, same thing. But then if we give an odd number, right, we get the 1. So even 0, which is an even number, follows this rule of if you take the even number and you modulo it by 2, it's going to equal 0. So that kind of tells us check for even or odd. So I could do like the digit I get modulo 2 equals 0, then it's even. So that's kind of handy. But I need to go, oops, sorry. Keep getting emails that I need to respond to. So now I need to go through, right, this number and get digit by digit. And I forgot if it was elaborate homework, but if you remember from last week, I believe it was, that if we have, pull up this, so let's say we have a number, 958. If we do the kind of like floor division, right, it removes the last digit. So then we can, keep calling that. So then we have 95, we get 9. So it's like, okay, I can remove a digit like that, but that's maybe not helpful right now because I actually want this digit so then I can do modulo 2 on it, right? So in the case of 958, I want that 8 somehow. So it's like, how do I get the 8? Well, again, another property of kind of doing modulo, where you get the remainder is, so if I have 958 and I do modulo 10, which is basically saying, hey, divide this by 10 and give me the remainder. So it can go into 958 95 times, and it'll give me a remainder of 8. So then, I get the 8, which is the digit I need. And, just to confirm, let's do it on that. So, it can go into this number, 97,824 times, and then it'll have a 9 as a remainder. And so it's like, okay, that is a way to get my digit. And then, just to test. Still kind of holds up, right? Because I get the 0. Okay, so that's going to be helpful. So let me, and then we can get a digit by doing modulo 10. So then, okay, make sure I have no questions. Okay, so that kind of gives me the digit, and so I can do stuff on it. And then in this case, right, so let's say we had 958. Let me do mod 10 on it. So I get the digit 8, and then I want to do the check for even or odd. And then, well, actually, let's do this case. All right, so I'll get 9, I'll do my check, it is odd, so I'll need to go through these other 2 digits, right? Because you need to go through each digit in the number. So modulo 10 gives me this, the kind of ones place, but I want to check the tens and the hundreds place next. So what you can do is use the floor division, which we used last time, to do that. And so that once I get the digit, which will be 9, then I can kind of remove it, quote unquote, by doing the floor division, which gives me 95. And then I can kind of repeat the process, right? So I can get 5, then I'll do that, then I'll just have 9, which will, still hold up there. So it's kind of a combination of using this floor 10, which we had used previously, but then also applying modulo 10 to it, which we had not kind of done explicitly with modulo 10. So maybe that was a little tricky, but I don't think there were too many questions on that. But again, if you did have trouble and you didn't ask anything, always feel free to post on Piazza or to shoot me a message if you want. If you get stuck, I don't want you floundering on a problem for hours. So I think we kind of have the logic kind of scoped out in a way to check. So then maybe we'd want to kind of start writing it. So we could do a while, which is also kind of on the one that we did the floor division on, similar with it. So we take this number, while it's greater than 0, right? So while it is a valid number. But then I think too of, okay, well, if it's greater than 0, how about the case where it is 0? Because it even mentions, hey, if it's 0, it's an even number. I was like, well, my while was going to do greater than 0 because it's a number. So I could do greater than equal to 0, or I guess another way you could do it is if, you could just put the hard if in right here. So if you do input 0, it's kind of an edge case, but kind of not. Then return false because 0 is an even number. So now I can just keep my thing as num greater than 0, which is most of the kind of loops people did for that one that was on the last homework or lab. So then my number is greater than 0. So I want the digit first, and we can get the digit by doing modulo 10. So then I'll take this number, mod 10 it. So I have my digit, and now I need to kind of remove that digit from my number. So we'll do the floor division. Now I need to actually do my check on if it's even or odd, right? Because we did these kind of 2 steps. Get the digit, and then basically remove that digit from the number. So it won't affect us as we continually loop over it. Let's do the check. So I have my digit, modulo 2 equals 0. So now this is, again, checking if it's even. So if this digit is even if it's the first one in the ones position right on the far right, then the whole thing needs to just return false because it's not completely odd. So then we can return false. So even if we have this massive number that's all odd, but this kind of ones is for it, which is fine because we're starting from the right and working over in this case. So if it hits this, it's even. We can return false. We don't have to worry about looping over the rest of it. So that'll return false. And otherwise we can just kind of continue looping over. And if this never gets hit, then the whole function will just return true. So let's run and make sure we did that right. Let's pass it in kind of a large. odd number. Okay. And now let's just copy the same thing and sneak an even number in there. Oh, nice. Okay. Let's also test the case where it's here, an even number. Okay, and we'll maybe test another one while it's there. Okay. So it looks like on some of the test cases that we just threw at it, it works. And yeah, that's kind of the whole function right here. And then here's kind of the logic thinking through it. So again, if there's any questions, let me know. Then we'll get to movie ticket, which I actually probably won't do the thinking process on. So it prints out the cost of a movie ticket based on the input age of who the ticket is for. It should follow these rules. So this is, again, just kind of getting you to do if statements based on some requirements put in. So if the tickets are someone below 6, so we have if age, which is the input number, below 6, so less than 6, then it costs $5. So, just print the costs. And, it's a single age input, and so we can do the elif, so like the else if, because we don't need to bother checking the rest if we already meet one of these conditions. Right, so, I mean, also we could structure it in a way where like it would never hit the other ones, but we'll just do elifs to, kind of have the extra reassurance. So this one is if the ticket is someone 6 or older. So 6 or older. So if you're greater than 5, then you are 6 or older. But you have to be below 13. So it's not an or, right? Because we want the and, because this is like the same condition. So you're greater than 5, but you're less than 13. Because you're below 13. Right? Print 6. And then we have another condition where if someone is 13 or older, put it there. So if you're 13 or older, then you're greater than 12. We could also do greater than or equal to 13. Doesn't really matter. We'll just do greater than 12. But you're less than 18. Okay. So just on 17, print the amount. 7. As it takes for someone 18 or older. So if you're 18 or older, then you're greater than 17. But if you're less than 65, then you're, well, less than 65. And then we'll print the ticket cost, which was what for that one is 8. As you can see, I struggle to find the $ key. And finally, if the tickets are someone 65 or older. Okay, well, we're just going to do an else because we have every other kind of case handled here. I feel like for age. And then we'll just print that. Let's do a movie ticket. So 5, good. How about 7? So 6 should also be the same, $6. Nice. What other case do we have? We have like 13, which we would expect to be 7. Then if you're like what, basically 20 to like any kind of range. But then if you're 65 and up, it should be down to 5 again, right? Senior discount. And then I guess it would work for anything huge, right? Yep. And yeah, that pretty much sums up the movie ticket one. So now we'll move on to average grade. Average grade, and it takes in a list. All right, so complete the function average grade, takes in, well, it's LST, but we'll see what it is. That takes in a single list, all right, corresponding to a student's name in the first index of the list. So, and so student's name in the first index of the list. So then I'm like, okay, is a name? This is if I'm just reading line by line, right? The list of the grade, first index of the list, and their grades in the following indices. Okay, so then I'm like list 1, 2, max are grades. and also, however big the list is. So maybe instead of like max or end of list, I could just say, how about the length of the list minus 1 are the grades. Here's an example of what it can look like. So we have a name and 4 grades. Okay, note there can be a varying amount of grades in the list, so it can be up to any size. Okay, right, I think we kind of got that. At minimum, it'll have 2 elements, a single name and a grade. Okay, so maybe list is always at least size 2, or, length 2, which is fine, good to know. But the first element will always be the student name. Okay, so what should this function even do then? This function should calculate the average of all grades present in the list and return a 2-element list containing the student's name and the average, like so. Okay, so I'm going to need to take that name from that first index, then I'm going to need to average every other value that comes after in the list. Okay. So then it looks like, so in my return, right, I'll need to return a list that has like a name and some average. So, maybe I'll say name blank, average, it's going to be 0. So I need the name from the list, and I know it's always going to be the first index, right? Or the first element. So that's going to give me it. And then average is going to be list to everything divided by the kind of total. So I'll probably definitely need to loop. I'll need to loop over every element of the list. Oh, hold on. So checking the YouTube thing. So for the movie question, why do you add that else at the end? Is that always necessary? So if I don't have this else at the end of the movie thing, then the case, so this handles the case where the age is 65 and up. Because I'm trusting all my other statements to get the case where you're below 65, right? Because this is below 6, this is between 6 and 12, this is 13 and 17, and then this is 17 to below 65 to 64. So I need my else because it goes back down to $5, right? So if I didn't have this, then if you input the age of 65, it wouldn't print 5 because it would not trigger any of these statements. Same if I typed in like 100. So, I mean, I could do like another, like else if your age is greater than 64. So if you are 65 or higher, that would be the same thing. But since I know these are all catching the case where you're basically 64 and younger, then I just throw the else in there. So you could also, or do like a elif age greater than 64, which would trigger this as well. So that's kind of why I just have the else, because I'm trusting all these to get the case where you're below 65. And then I do need something to print 5 if you're 65 and higher, so that's what the else does. Yeah, or I mean, you could also, well, yeah. And if I didn't have the else, if I just had like print 5, then if it hit the if, it would print this 5, then it would like print the 5 again. So I do need something to trigger it, if that makes sense. Yeah, so on the list, so again, we know the first element is going to be the name, and then if I need the average, so I need to add all the kind of remaining elements here. That kind of tells me, oh, maybe I'll need to loop over them, right? But I can't just loop over the entire list because I know that first element is the name. So I can make a loop. Let me do this little thinking thing. I need a loop of some sort to get all the grades added together because, I need to calculate the average. But I can't loop over that first element and treat it like a number because it's going to be a name. So I'll need to kind of account for that in my loop, which you can do. But another way that is maybe a little cleaner is if you remember, which I don't think we actually used it that much, but we did talk about it briefly, is if you have a list, you can call pop on it, which is kind of the same as removing an element. So pop takes in, and we can go to the W3 school sync on list if we need to, but pop takes in an index to kind of return, and it removes that item. So if I have this list and this example, and I call pop 0, it's saying, hey, go to the 0 index of the list, remove that item, but also return it. So I'm able to assign things to it. So my variable name, I can do pop 0. So it says, hey, remove the first element of the list and return it. So I'm able to assign my variable name to it. So now after this, so right, if I have, list is equal to a name and then some values here. Now after I call this whole little pop thing, my list now just becomes this. All right, so it's just the grades I need. And keep average at 0. So it makes it a little easier for me to just loop over, because then I can just do like a straight up for loop on it. I don't have to account for this case where the first element's name, because I've got it in its place already and I've removed it. And there's a lot of ways you can remove elements from arrays, or you could just kind of bake that into the for loop where it just skips the 0 index. But this is the kind of way I like to do it. Yeah, so now let's get to that kind of for loop where I want to loop over the grades. So if I know my list is just numbers now, then I can just do, for x in my list. So this is saying, go for x, where x will be each element in my list. So it just says, hey, walk through the list and give me each element, which I know now are numbers. So then I can just do that. Again, that's equal to doing that. So now I can go ahead and kind of add all the grades up. So in this tiny example here, by the time I loop through the 3 elements, average will be, 20? Which is good, but then that's technically not the average, right? That's just the sum of all the numbers. To get the average, I will need to take the sum of all these numbers and divide it by that many numbers, because that's how you calculate average. So if I already have the sum, in this case I would need to divide it by 3, which is also conveniently the length of our list. So then, well, you don't have to do it down here, we just do it here. So now, since I popped it, right, so my list is only 3 now, and I did add 3 elements, I should be able to just divide it by the length of the list, and I can just go ahead and throw that in here since we're returning a list. And I think that'll work. Let's try it with this example case because we have some input to go off of. So then we have average grade. Of course, it doesn't want to copy and paste nicely. So then I expect it to return this based on that sample output. And it looks like it does, which is nice. And so yeah, that's kind of one way to do it. You could have a for that kind of bakes it in. You could have like another counter and try to avoid the first index. But since after the first one, the rest are numbers, I think it's probably better to just kind of assign it to that first one and then do one of the many ways to kind of remove that first index. So that's what we did with the pop. And yeah, that's I think that's the lab, right? So not too bad. So I think if there's no more questions, or even if there are questions, definitely feel free to type them. Also, end of lab review. Just doing that for people that watch the video after the fact, so they'll know. So what was that, like 5 minutes into 40 minutes in is all the lab review. Now we will cover useful homework 3 tips, hints, particularly for the word match one. Yeah, so I think I'll probably dive into the homework a tiny bit. And again, if there's questions in the lab or why I did something one way or the other, or questions about this kind of homework view, definitely chime in. What are we on? Homework 3. So pizza order kind of starts to get at an element of word match, which is basically what if you take in a word like onion and I have to match it to onions because it's plural, right? The topping list that we have defined for us is like all plural. So it's like, okay, how do I manipulate an input kind of word to get this other word? Question. Is there another way to do average with sum that would work in the case of the last question? Yeah, I think so. Actually, I'm blanking on what sum does, but so we just call that right now. All right, we do it like this. Right. Yeah, so yeah, I mean, that's actually probably like way easier to do instead of the for. So another way you could do it is, I'll just gonna blank that out now too, is now that we removed our list, so we could just do average equals sum of the list divided by the length of the list. So that's actually like a way cleaner way to do it, I would say. I mean, now the whole thing becomes 3 lines. Not that you should really kind of judge like the quality of the code by the quantity, but so I mean that looks right. Yeah, so that's totally another way you could do it. That kind of avoids using a for. So good question. Yeah, that's also totally right if you did it that way. There is no like forcing of using a for. I just figured most people might do a for since we just kind of came from that unit. Yeah, sum totally works. I think there's also like a statistics package for Python. Statistics. Yeah, that you can call like mean to. I've actually never used the default. I think it's a default package. Not to go on like a tangent, but so it looks like it works. Let me do. Can I do that now? Yeah. I mean, so that's also another way to do it. That you're welcome to do. I've actually like not explored this. I've used stat packages before in Python, but not kind of the default one. But it looks like it gets the kind of measures of central tendency. So I mean, that's I guess a potential another one. I know, yeah, I don't think we'll ever use like standard deviation or anything. It's getting too mathy. But yeah, that's a possibility. There we go. That's the lab. Don't need that. Yeah, so pizza order, right, kind of gets something we might have to do in word match, which is like you take an input word and it's really close to another one, but it's off by a letter. In this case, it may not have the ending S. So you need to also like account for that case, right? And so we'll just pull up this. I don't think I'll need this anymore. So let's say we have a word that's like onions, and you need to match it to onions, right? So pizza having word match, no, it does not, obviously, because there's this extra S. Um, and that's kind of like the only case for pizza, right? Is like you may get an input topping that should match, um, and it's based on if it has the S or not. So if you do input onions, then like, right, it'll go ahead and match. So if you have like an if, and you're iterating through maybe the order, and then you iterate through the toppings, and you say, hey, does this word match? And then yeah, put semicolon here and do stuff, or colon rather. Um, but if our word is just input like that, then one way to kind of add the S would be that. So like, does this equal it? It does, because now even though our word's this, if you do that, it does become onions. which is the same. So you can add an S to it that way, but you don't want to always add the S, right? Because like you may have the case where you already do get onions passed in. Then if you do that, it becomes onions with two S's. And so it doesn't match anymore, right? Because we have that extra S. So you wouldn't want to always just kind of blindly add that S, because you may actually get an input that has it already pluralized. So there's maybe a condition or a conditional that you might want to check for. Hey, does this word, which corresponds to like an input order topping, right? Go ahead and end in an S is maybe one way you could do for it. So, I have my word. And don't forget, we can kind of treat words similar to lists where we can like index and they have lengths. So I know that. Okay, it's 6. So then my fifth index is going to end in an S. But that's for the word onions. Like, right, what if you put in word 2 pepperonis? Then, right, obviously the fifth index is going to be something different. But I do kind of like one way to check for an S, right, would be to check the last letter in the word. So again, for onions, that would be index 5, which is equal to the length of the list, which is 6, right? Because there's 6 characters in onions. That's what, 3, 4, 5, 6, minus 1. So it gives us S, right? Because it's length of the word, which is minus 1 because we're 0 indexing. And then that should apply also, right, for pepperonis, which is much longer. It does give us the S. So if in my kind of like, in this pizza function, right, pizza order, if I did want to add an S to the word and then check it against the toppings list, like doing some kind of for loop, iterating over the items, instead of just blindly kind of adding an S to everything, maybe I would want to have a little check right here. Does something like that. And say, hey, if it's not equal to S, right? So basically this is saying, hey, if this input word, which corresponds to like one of the order toppings here, if it does not end in an S, then let's go ahead and add an S to it, right? And then do a check for it. Or, you could also just have, if it doesn't equal an S, then you could just have another check in here, which admittedly might get start to get messy. Or not is, but like in toppings. And then, so what you can do again in toppings, which is similar to what we did in the lab, if you're not familiar with the in cat annotation. So here we were looping through letters of a word, and then we have this vowels list. So we're saying, hey, if this letter is in this list, so that's kind of similar to what we might do for pizza toppings, is hey, we have this topping that was placed into this order param. Is it in our toppings list? So that's what we do here. So we add an S to it because it doesn't have an S, and we know all toppings are unfortunately pluralized. So we say, hey, if, onion plus S, so onions is in toppings, which case it is, well then technically we want to do nothing because it's good, right? We don't have to print out that we're adding because it's already there. So you could just say, do nothing. You wouldn't want to print anything. You just tell it to continue. Yeah, so that's one case. Or, you could do like not in toppings. Print. Adding, and then, whatever it is. Or 2. You could throw the S on it if you want. Something like that. So, it doesn't end in S. Let's add an S, see if it's in that toppings list. Oh, it's not in toppings list? Well, let's print that we're adding it, like the instructions say. Sorry, there's some hints for that. Just ended a discussion on pizza toppings. So now let's go down to word match, right? So if you read word match or if you looked at the office hours from last time, and you see the instructions, we have to handle the case where it's modified. So like adding a single letter to the start. to the end or modifying somewhere. Yeah, the word. Right, so those are the cases. So in here, we just did the case where we're adding it to the end. So what would be helpful for that? So basically, I guess first off, we're doing this. We have an input word and a list of words. So let's do like hello, love me some Adele, word song. Right, so now we have some sample input. We're gonna want to check. So we know that this word could match any of these cases. So, if we did like T-song, or if we did like songs, these are like potentials that it could match to, or if we did like sang, it would match right because the O becomes an A. So what's that telling us if we add a letter to the beginning or end is it's kind of getting at like the length, right? So the length of our word is 4. And so, one of the valid variants is if we just pluralize it, or if we add something to the beginning, so 5. So a good check that might help us out from kind of iterating through everything is, hey, if, for W in word list, so for each element in there, if the length of the word is greater than the length of our input word plus 1, then we'll like disregard it, right? It cannot be a match. Because like song would never match, well, these words kind of fit, like some huge word, right? Like pepperoni. No matter if you made a bunch of modifications, because you'd have to add like so many letters, and at most we can add a single letter. So a good check to have that could help you kind of narrow in some of the logic would be checking the length. And the same could kind of go for like less than. So if the length of a word in the word list is less than the length of the word, then it'll also never be a match. We're on to word match, right? Because there's nothing mentioned in here about subtracting, right? It's either adding to the start or the end or modifying one. There's nothing about removing it. So, if our word song, like sun, would not match. Because we don't do subtraction. We only do addition. So another check you could have is, hey, if the length of one of these words in a word list is less than our input word, then it's just not going to fly, right? Because we don't do the case where it's less. Only if it's more, as we just had it on. So that's kind of a useful check. And then if it is, right, so then if we do have a case where, a song is the same length as from, so we're on like word list item 1. And then we're going to want to compare characters, right? Because one variation is song matching like the word sang. So let me just, song should match like sang. It could match like, I don't know. You could put like any letter here, etc., right? Or even, tong, whatever. Basically, if you can make one letter modification, it should match. So to kind of check that is we should maybe iterate through each letter of a word in the list. So if we're doing, we have a for loop, right, that's already taken us for the word in the word list, right? And so now our word, let's just go ahead and assign it to be this. Whoop, that's a 1, not an L. So now 4. So now if we do like 4, okay, so that's, remember, that's the way to get the letter, which we talked about in the lab. So I will probably want to list over each letter and try to compare it to our word, which was song, which I actually just assigned over. So we'll do that. So I'll kind of want to see, hey, is in the letter. I wonder if I can do like SNW. Okay, so you can make use of the in keyword again. So perhaps one variant would be to loop over each letter in word and then loop over each letter in the input word and try to compare them, which is fine. I mean, it does get a little taxing because then for each letter, you're iterating over like each letter in the word list. So that becomes, like a lot of kind of for. And I think at that point, we would be embedded in the for loops like 3 times or 2 times. I think 3 though. So it can maybe be confusing. Um, but if you're already looping through letters, so C, then I could have, I'll just retype it, for C in word, you know, if C, so if this letter is in our word, then we're good. So then maybe if C is not in it, um, so you could have like a mismatch counter saying, okay, like this letter doesn't line up, let's increment mismatch, which is maybe just some value I have. All right, so mismatch equals mismatch plus 1. Right, I don't have mismatch defined anywhere. So, we look at the first letter F. Is F in our word song? No. We'll increment mismatch. Okay, let's look at R. Is R in our word, which is song? No. And so we've already found 2 letters that aren't in there, which breaks our case, right? Because the only case we're looking for now is when it's off by a single letter. So like song would match tong, but it wouldn't match like that, right? Because it's 2 letters off. So then we could do a check for, hey, once our counter basically gets greater than 1, we can just disregard this word altogether. We don't have to check from anymore because we already know it's more than a character off. So we are running out of time, and I do have a meeting I need to attend to at 1, so I'm going to have to call it here. But hopefully that was kind of helpful on some logic you could use for word match. Again, don't flounder with it too long. If you're already into trouble, feel free to like share your code with me and maybe ask, or like, hey, how would I, especially I think it's best if you kind of do one of those things that I try to start with functions with, where you think through the logic kind of line by line. And then your question could be more so like, hey, like how do I am able to iterate through each letter in the input word. How do I compare each letter to like a word in the word list? And then we could talk through the code that way. That's maybe a little better than linking like, 20 lines of code and being like, hey, what's wrong with my function? Um, but instead like, hey, how would I do X? Like I'm able to get to this point. I have a letter in the word. How do I compare it to all the other letters now? And then, you could be like, well, maybe you'd want to take a four to do blah, blah, blah. So that might be better. But again, if you're like, oh, it's like 4 hours on this function and I feel like I haven't made any progress, like definitely do not hesitate to post on Piazza, to ask questions. Your peers can maybe help you out. I can definitely help you out. My response time is pretty good. Hopefully you want to keep it that way. So yeah, I don't want anyone struggling too bad on this homework, but this one should be challenging. It's intentional. That this one's a little more than the previous ones we've done in terms of this function. The rest shouldn't be that terrible. And hopefully kind of fun. I'm rock, paper, scissors, classic game. But yeah, so that's everything. I will get grades out this week. So I'll probably have them finished by tomorrow. And then the homework and lab for the following week will be out probably by Saturday. I might have a chance to get that lab out tomorrow. Depends how much longer the rest of the grading takes. But yeah, if you have anything I didn't cover, feel free to post on Piazza or shoot me a message. Yep. Good luck with everything, and I hope y'all have a nice weekend and don't spend too much time working.